Hi guys, I'm Dr. Rick Kopke, CEO of Ear Institute, and this is...
I'm Dr. Matt West, Head Molecular Biologist and COO of HEI Institute. We're coming to you live from one of our spacious and glorious labs here at HEI.
God opened a door for me to do some basic science research as part of my fellowship training in otology. Because I was in the military, I was very sensitized to noise-induced hearing loss. One of my first assignments was to develop a medication that could prevent the toxicity to the ear from a chemotherapy drug called cisplatin. We came up with this drug that really prevented that hair cell death, and I got thinking, gosh, I wonder if oxidative stress, like we were seeing in this petri dish with cisplatin, plays a role in noise-induced hearing loss that could be developed by overdriving the inner ear with too much sound. And lo and behold, that was the case.
I think we're finding now that we have a kind of a new vista of hope with the technology, and that we can see that there are some unexpected, serendipitous kind of findings associated with the technology, and that we can see regeneration of nerve endings after the trauma has been induced and set in. Now we're really excited about some potential for long-standing hearing loss implications, so the ability to regenerate these sensitive nerve endings and restore a natural degree of hearing quality.
Finding that these little nerve endings could be regenerated and function again opens up a lot of different possibilities. Tinnitus and hearing clearer, maybe not getting rid of hearing aids, but helping hearing aids to work better, helping people to actually understand what people are saying. There's increasing evidence over time of a strong correlation between hearing loss and Alzheimer's disease. People with sensorineural hearing loss have a much higher risk of having Alzheimer's disease, and people with Alzheimer's disease also have a high incidence of hearing loss. We don't really know if one causes the other. All we know at this point is there's a strong correlation. People with Alzheimer's disease have molecular evidence of the disease. Sometimes this can be picked up on special scans. You can see these pathologic changes of Alzheimer's disease in all these different areas of the auditory pathway. One of the key toxins in this is a tau protein or peptide that becomes modified and becomes toxic.
The tau protein that Dr. Kopke is talking about is a normal protein in the cell, located typically at the nerve endings. This protein, under conditions of excessive oxidative stress or inflammation, it starts to become like a snowball rolling downhill, in that it can subjugate normally functioning tau that can then spread from cell to cell. In that way, there's a lot of overlap between the types of damage that's going on inside the tissues and associated with hearing loss or auditory traumas, with those that are associated with some of the chronic neurological diseases we're describing.
This pill technology seems to robustly prevent the accumulation of tau. Even more preliminarily, seems to reverse the tau that's already accumulated. This could really be effective for Alzheimer's disease.